Hello, Algebra 1 class. This is Miss Odell. It's Thursday, September 30th, 2021. Today we're going to be doing section 1.10, which is properties of algebra. All right? Follow along with me in your book. I'm beginning on page 38 at the same time, okay? All right, the first property we're going to talk about is the commutative property. The commutative property is basically used, and by the way, you need to be taking notes on this section as well. This property is basically used stating that you can rearrange addition or multiplication and still get the same answer, okay? So, in other words, just like you see here, if you are adding 4 plus 5, that's also going to equal to 5 plus 4. Like saying if this is A and this is B, this is A and this is B. You can switch those without changing the value of the expression or the answer. Okay? That property also applies to multiplication. So let's just say AB equals B times A. Let's just say that A is 4. Remember, when you're multiplying like this, you put in parentheses. Equals 5 times 4. And yes, that's 20 equals 20. So that property basically only applies to addition and multiplication. Okay? Now, move on to the next page, 39, and we're going to talk about the associative property. So as you're taking notes, if you need to pause the video and write things down, please do. But you need to make sure that you're taking notes for section 1.10 with today's date, and that needs to be in your binder. Okay, so the associative property. Now, this is where you're dealing with groups. Okay, so you're dealing with grouping. You guys know what grouping is. And it deals with the grouping with the order of the add-ins, or the numbers that you're adding, or the factors, the numbers that you're multiplying, okay? So if the order has changed when the numbers are grouped together, then one of the associative properties have been applied. Therefore, if you see that you have a grouping of A plus B plus C equals A plus B plus C. In other words, it tells you here the add-ins, which are the numbers, may be grouped differently without changing the value of the expression. So you're going to, when you see this equal sign here, you know that you're going to get the same answer. Okay? Now, let's try one here. Let's say we have 3 plus 4 plus 1 equals 3 plus 4 plus 1. Now, in this case, you have no distributive property. I don't want you to get that mixed up because we've been working on that. But basically, if you add 4 plus 1, you're going to get 5, and then 3 plus 5 equals 8. Here, if you add 3 plus 4, you get 7 plus this one here also equals 8. Multiplication is the same. And this, again, only works for multiplication and addition. So, again, if you have A times B times C, remember, when you put parentheses like that, you are multiplying if they're right against each other, and there's no addition or subtraction in between. Okay? So let's just say that A is 3 times 2 times 4 equals. Okay? So 2 times 4 is 8, and then 8 times 3 is 24, and you're going to find that that equals as well. 3 times 2 in parentheses times 4. In this case, you're going to get 6 times 4, and that's also going to equal 24. Okay? Next property. This time we actually touched on this earlier this week, and this is the distributive property. Okay? And the distributive property, and actually you're going to go over to page 40 at the very top of the page. And as the textbook says, recall that we applied this property earlier. But it also it offers an alternative method of simplifying. But the order is still usually more efficient when applied to the algebraic expressions when you have variables in that, okay? So this may help you guys, okay? So let's just look at the first one here. All right, so if you have 2 times 5 plus 6 equals, you're saying that you are distributing this, you're multiplying that times that, and you're multiplying that times that, saying that this is A, B plus C, okay? So it's saying that essentially you're going to be multiplying A times B plus A times C, which goes 2 times B plus 2 times C, which is 6. Then, of course, you're going to do your multiplication first, which is 10 plus 12, and that is going to equal 22. Okay? That applies the same with the number on the outside of the opposite side of the parentheses. You're going to do the exact same thing. Okay? So you're going to have C times A, that's how you get AC. C times B, and that's how you get BC. You always list the first letter that comes in the alphabet first, okay? Let's move on to the inverse property. Oops, it looks like I have the identity property. All right, identity property, I might have missed, but it's on the same page, 41, but it's at the very top. All right, identity property. Think about the names of these properties. Okay, so the identity property of multiplication is that, and this is probably the one you use the most often, but it allows for the addition of fractions that originally have unlike denominators. So to obtain a common denominator, you must multiply each fraction by a factor that is equivalent. All right, so in general, this property produces a number equivalent to the original number. Okay, so the goal in this one is to get the answers to be the original number that you started with. Just like they say here, A times 1 equals A. 5 times 1 equals A. So whatever you're multiplying it by, you're going to get it's whatever the original number was. Let's look at the addition part, and then I'll show you another example. Of course, A plus 0 equals A. So the sum of a number and 0. So when you're adding, you're always adding that number and a 0 typically, and you're going to get that number. Now, let's say that you have a fraction problem, such as 1/2 plus 1/3 equals, all right, so you're going to then multiply this fraction by the factor of 1, all right? So you're going to take 1/2 and you're going to multiply it by this fraction by 3/3, because that actually equals 1. 3/3 equals 1, but it's also going to give you the common denominator. And then you're going to do 1/3 times 2/2, which equals 3/6 plus 2/6, which when you simplify, you get 5/6. Okay? So in this case, you'll probably see less of it right now in the fraction form, but you will have that, so you do need to keep that in mind. But there we go. The inverse property here is on page 41. All right? Now, inverse property basically is used again for addition and multiplications, And this property is very often used in algebra, okay? Okay, so the inverse property. Basically what it's saying is, so from any number, or if that number is represented by A, some other number may be added back to it to get 0. So basically the inverse is a good way to put it, because you're adding the opposite and that gives you 0 when you're doing addition, okay? So like if you're going to add, like, so let's look at this rule here, and you have A plus a negative A, of course we know that equals 0. You have 5 plus a negative 5, that's going to equal 0. So that's the inverse property for addition. The inverse property for multiplication guarantees that for every non-zero number multiplied by itself, by its inverse, equals 1. So when you're looking to identify the property and you see that it equals 1 because you're multiplying by its inverse, equals 1. So what is the opposite of, let's just say, 2? The inverse of 2 is 1/2. Because actually 2 is the same as 2 over 1. So the opposite of that is 1/2. Okay? So A times 1A equals 1. Now, an example of that would be is 2 times 1/2 equals 1. Because when you put this over 1, you multiply 2 times 2 is 2, 1 times 2 is 2, and 2 divided by 2 equals 1. That's your inverse property. So you're using the inverse operation, okay? All right, let's move on. Let's review. Let's go back to these properties, and then we'll practice a little bit before I give you your assignment. So, again, here's our properties that we had. The first one that we talked about is the commutative property. So remember that you're adding, if you add A plus B, that is also going to equal B plus A, okay? And then in that case, the multiplication, you can multiply A times B is also equal to B times A. Associative property, this is where you can move the grouping as you had A plus B plus B plus C in parentheses. Well, you move the grouping here plus the C and you got the same answer. Same thing with multiplication. The distributive property, you are distributing A times B plus A times C. Here you're just doing C times A. Of course, you're going to do A and C first. You're going to do A first because it comes before C in the alphabet. And then C times B, which you're also going to have B times C with your addition in the middle. Identity, A plus 0 equals A. A times 1 equals A. It's identifying itself. Here in the inverse, A plus a negative A equals 0. A times its inverse equals 1. Okay? So notice in this situation, we have 2x plus 5 is equal to 5 plus 2x. Notice that this 5 is the same. The places have just been changed. So what property do you think this is? And you can use your chart to refer back to. This is the commutative property. One way that I like to tell people is that these terms like to live in a community, so they visit around, they go visit each other. So 2x and 5 change places. They were visiting, so they were a commutative property. That might be a stupid way of understanding, but it's my way and it helped me. So the next one here is if you have 7 plus a negative 7. So what is the inverse of 7? Negative 7. And that equals 0. So think about your inverse property. When you are doing that, you are going to get 0 for addition and 1 for, typically for multiplication. You're not going to get 0. So think about that as the inverse property. All right, let's look at another one here. Well, let's look at 4 plus 0 equals 4. And this is the identity property. How do we know that? How do we identify? The 4 is identifying itself. And it is doing that by adding 0 to it. It wants to be by itself. So it's identifying by itself. Okay? Let's look at another one here. We've done community, inverse, identity. Of course, let's look at a distributive property one. And let's see what we got here. All right, so if you have 2x plus x plus 2, that is going to equal to 2x times x, which is 2x, times x, plus 2x times 2, which is 2x times 2. And that's basically what you're doing when you're doing the distributive property, but let me go ahead and simplify that for you. Okay, so 2x times x is 2x squared, plus 2x times 2 is 4x, and that would be your final answer there for the distributive property. All right, so let's look at another one here. Let's say that you have, all right, so let's say that, of course, let's just review the associative property. That's saying if you have A times B times C, you can get the same answer by multiplying A times B times C. A number example for that would be, let's say you have a 4 times 3 times 2, and then you go over here and you change it and you have 4 times 3, 4 times 3 times 2. Okay, so what did you do here? Well, you changed the association. You changed the parentheses. And when you did that, then you will still get the same answer. And that's telling us that through the equal sign. 3 times 2 is 6, times 4 is 24. 3 times 4 is 12, times 2 is 24. And that is what you get for that. And that is the associative property. Okay? Do your best at these. Take your time. You can also look on page 42, and they have some more examples there as well. And your assignment for today is going to be, all right, so let's just go here next. And so here is your assignment. Of course, it's also on LMS, ASSI. All right, so you're going to do 1 through 14, okay? And this, of course, is coming from page 43. You can do this in your book and then send me a picture of that. But guys, make sure that you are writing what property is. I don't want you to write things like, I don't know, false, I saw that from another page. Don't go through and just write down whatever you think. Actually use these properties and identify them. And of course, please let me know if you have questions. I'll always be here to help you. All right? Thank you. Have a great day, guys.